Hey everyone, welcome to another math video. In today's video, we're going to be talking about the elimination method. Now, the elimination method is another tool that we use in order to help us solve a system of equations. So let's go ahead and let's get started. Now, in order to use the elimination method, it's handy to have both of your equations written in standard form, which is what we have here with these two equations. Now, sometimes it's called the addition method, depending on who's teaching it to you. But essentially what the elimination method does is it eliminates one of our variables. So by adding the two equations, we are going to eliminate either x or y. That is the goal of the elimination method. And we're going to take a look at three different problems in which we have to take different steps of using the elimination method. In this first one, I can see here that if I use the elimination method by adding these two equations, so I'm going to go ahead and sort of make this a big addition problem. We are going to go ahead and add these two equations, okay, which is usually one of the first steps if you can see that something is going to cancel if you were to add. And later on we'll see examples where I'm actually not able to add right away. I have to actually do something else. But for this problem, I can't add right away, and the reason why I know that is because I can see here that the y's would cancel if I do that. If I add a negative 4y and a positive 4y, those both combine to 0. So if I add this whole thing together, 2x minus x, that would simply leave me with ax. Okay, you can write a 1x if you really wanted to, but I just simply write x. Negative 4y plus 4y, we already discussed that that was 0. And 2 plus 3 is 5. And I don't really need to write this 0 down. I can simply erase it because 0 is not adding anything of value. It's the same as if it wasn't there. The equation really didn't change. So right off the bat, here we have that x equals 5. And that's the nice thing about the elimination method, is that sometimes I can get my first variable very quickly. And then what we do to find our second one, so we know that x is 5. I'll write that down here. I'm going to go ahead and recycle one of the first two equations. Okay, I'm going to go ahead and use the top one. And I'm going to plug in x into it so that I can find what y is. So here I have 2x minus 4y equals 2. I'm going to go ahead and substitute 5 in for x because now we know that that's what that equals. 2 times 5 is 10. Minus 4y equals 2. And here now we have a two-step equation. I'm going to go ahead and subtract 10 from both sides. That'll leave me with a negative 4y equals a negative 8. I can then divide by negative 4 on both sides. And I'm going to go ahead and move this problem to the right. If I divide by negative 4 on both sides, that would leave me with y equals 2. So for the first problem, we know that our answer, okay, we now have our x and our y, but together, our answer would be 5, 2. And this is how we use the elimination method. And like I said, this problem, it was quite nice because we could add right away because we saw that the y's canceled out immediately. Okay, I didn't have to change any of the equations, but there are some times where we're going to have to change the equation. And that's what this next example is about. So here I have an x plus 2y equals 4 and a 2x minus 5y equals negative 1. And we'll go ahead and we'll just add this, acting like we believe that something would cancel. And what you'll see is that I'm going to have x plus 2x, that's 3x, 2y minus 5y, get minus 3y, 4 minus 1, that's just 3. Notice how I didn't get my x or my y to cancel. None of them were eliminated. Okay, so that's already a red flag saying that, okay, I need to do something different. So what we're going to do for this one is we have to determine, well, I should be able to change one of these. And the way we change this, the step that we would do here is we're going to have to decide which equation we want to multiply and what number we want to multiply by to that equation. So the goal would be to either turn this x into a negative 2x so that it cancels with this 2x on the bottom, or we can change this 2y into a negative 5y, which, as far as I know, there's no way to change a 2 into a 5 by multiplying unless we use fractions, which I'm not a big fan of if I can find a whole number to multiply by instead. Which I know how to change an x into a 2. Okay, I can definitely do that. And what you'll see is that if we can multiply this top one, okay, and the tricky part sometimes is just finding this number that we need to multiply by. But just ask yourself, how can I change an x into something that'll cancel out with this? Well, if I wanted to cancel out with 2x, I want it to be a negative 2x. So I'm going to multiply by negative 2. And the new equation I would get, because I have to multiply the whole equation by negative 2. Negative 2 times x would be negative 2x. Negative 2 times a positive 2y would be a negative 4y. And negative 2 times a 4 would equal a negative 8. And we got to make sure that we multiply the entire equation. Now what we're going to do is the bottom equation is not going to change at all. That one is going to stay 2x minus 5y equals negative 1. We're not multiplying that one by anything because there's no need to. Now I can go ahead and I can add these two. And this is one of the reasons why they call it the addition method, is because you can add the two equations. I call it the elimination method, and that's what most people refer to this as. Negative 2x plus 2x, that'll be a 0. Negative 4y plus negative 5y, that is a positive, or sorry, not a positive, a negative 9y. Negative 8 minus 1, that would also be a negative 9. Again, we don't need the 0. 0 does not add anything to our equation. And now here you can see that we could divide by a negative 9 on both sides. And we get y equals 1. So now we know what y is. Y equals 1. And now we have to find what x is. And we use the same thing, we do the same thing we did last time, where I can pick any of my original two equations, one of these two, to plug in y. I'm going to go ahead and use the top one. So, doing so, we would have x plus 2y equals 4, and that was just me copying this top equation right here. I can then substitute the one that we just found. So we would have x plus 2 times 1 now. And again, that came from the highlighted area. So that would just be x plus 2 equals 4. We can then subtract 2 from both sides. And we end up finding out that x equals 2. So there we have. We know that x is 2 and y is 1, so that would make our final answer 2, 1. So this was the second example of what we would do in an elimination problem if we didn't have both of the equations canceling out right away. Now in this example, I only had to multiply one of the equations by a number. I had to multiply the top one by negative 2. There are also some problems where we're going to have to multiply both equations in order to get something to cancel out. So let's go ahead and let's take another example where that would happen. Here I have 4x minus 3y equals negative 9, and 3x plus 2y equals negative 11. So what I would have to do here is we could look at this and we'd see that there's no way to change a 4 into a 3 or a 3 into a 4. Okay, I can't multiply 3 by anything that'll give me a 4 unless it's a fraction. Again, which most often we don't want to go into those. Likewise with the y's, I can't make a 2y turn into a 3y by multiplying by some number unless it was a fraction, which we really want to avoid. So what we got to do is we got to decide, well, what can I change both of them to? And we find that number by thinking of common multiples that 3 and 4 have in common for the x's, or that 2 and 3 have if we're trying to eliminate the y's. You can choose which one you want, in general, my rule of thumb is try to change them and multiply by the smallest numbers. So for example, the 3 and the 4. 3 and 4 can both multiply into 12. Okay? I can multiply this top equation by a -3 and the bottom equation by a 4. This would result in the top one equaling -12x and the bottom one equaling a positive 12x. That's one option that I have. If I want to cancel out the y's, however, I have to do a little bit less work simply because the y's already have an opposite sign. I have one negative y and a one positive y. So I don't need to multiply by any negatives like I would have to if I'm trying to cancel out the x's. So for that reason, and because the numbers for y are smaller, 2 and 3, I'm going to go ahead and try to make those the same. So for the top equation, I'm going to multiply the top equation by 2. Simply because I know that 2 and 3 can both go into 6. 3 times 2 is 6, and 2 times 3 is 6. So I'm going to multiply the bottom equation by 3. Okay. So the top one would leave me with 2 times 4, that is 8x. 2 times -3 is -6y. 2 times -9 would be -18. And on the bottom, we would have 3 times 3 is 9x. 3 times 2 is a positive 6y. And you can see here, this is why we're doing this. I got my y's to both have the same number with opposite signs. 3 times -11 is -33. And now I can combine these. Now I can add them. 9x plus 8x, we would end up getting 17x. The y's would cancel out. -18 minus 33 would equal a -51. I can then divide by 17 on both sides, and I'd find that x equals -3. So now I know what x is. And just like the last two problems, what we do now is we are going to take one of these two original equations, plug in x, and find out what y is. Now, if you wanted to, you could also use one of the blue or green equations. They're the same equations, you'd get the same answer. I'm going to go ahead and use the bottom one for this case. So I'm going to take 3x plus 2y equals -11. And I'm going to substitute the 3 in for, not the y, sorry, but for the x. That would leave me with 3 times -3 plus 2y equals -11. I would have -9 plus 2y equal -11. We can then subtract or add a 9 to both sides, leaving us with 2y equals -2. We can then divide by 2 on both sides, and we're left with y equals -1. So now for my final answer, I would have -3, -1. And this is the most complex that the elimination method can get if you have both equations in standard form. So hopefully now you feel like you can use the elimination method to solve problems. As always, you don't have to use the elimination method if you like another method better. If you're all about visuals, you might prefer to graph, and that's okay. Graph the two equations. If you saw the substitution method and fell in love with it for whatever reason, go ahead. There's a lot of people that would prefer the substitution method over the elimination method. Sure. If you like the elimination method because you feel it's faster, use the elimination method. At the end, all three methods will give you the same answer, and they just give it to you maybe in different times depending on which one you're more comfortable with. Always do what you're more comfortable with, and always learn that way. Nothing to be ashamed of you preferring one way over the other. As always, I hope that you continue to learn through these videos, and I hope to see you guys next time.